and give it a go. So my project, I'm a master's student at the University of Vermont under Mark Henderson. I'm modeling predicted distribution of the invasive around Goby and Lake Champlain before they get there, hopefully. It's a collaborative project with me, Peter Esselman of the Great Lakes Science Center in Ann Arbor, Michigan, Ellen Marsden, and then again Mark Henderson.
I think the battery might be dying.
Let's a little bit about the behind the podium and we get better signal.
Now nothing's working. How far did jelly go?
Had it working.
It was working.
Yeah, it worked.
She's
Yeah.
going to blame it on me for sure.
Had the first
Down arrow, what else might work?
Is the mouse?
Try space bar? Okay.
That wasn't me.
That was me.
You gotta try it.
Oh,
Yeah, okay,
we're back.
Next one,
Okay.
okay.
Yeah. Cool. All right, so to back things up, around Goby's native to the Caspian Sea, Black Sea, and Sea of Azov, and their associated tributaries on the border of Europe and Asia. You can see the invasive versus native range map in the bottom left, the red where they're invasive, green where they're native. They were originally transported to North America via ballast water from commercial shipping vessels, similar to the one that you see in the bottom right. And I'm glad that Scott's video didn't work of the maps because I have some pictures from that as well. So in 1990, they were first discovered in the Great Lakes system in St. Clair River in Michigan, where that red star is. 5 years later, they were discovered in all 5 Great Lakes, including Lake Superior, near Duluth, Minnesota. You can see a point in the top left, providing further evidence that commercial shipping vessels are their likely mode of invasion. Now fast forward to 2024, where they've radiated inland through all the tributaries and their associated man-made canals, east and to the south. So that's kind of where we are now, which in these invaded habitats, in these invaded regions, specifically in the lake systems, they've shown seasonally differentiated habitats. So in the summer, they're more in shallow waters, less than 20 meters. Kind of the optimal range seems to be in that 10-meter range and even shallower. They prefer that rocky cover, that vegetative cover, kind of hiding in that substrate. In the winter, they disperse in the more open offshore habitats, deeper than 30 meters typically, but they still kind of spread out everywhere. Studies have kind of tried to correlate this round Goby presence and abundance with some of these habitat characteristics using the information from that seasonally differentiated habitat, so season, water depth, water temperature, and benthic substrate type. And when I think of benthic substrate type, I'm talking about hard, so cobble, soft, sand or mud, and then vegetation as well. In these invaded habitats, they've had plenty of adverse impacts, one of the number one being that they're outcompeting our native species for resources, for food and habitat. So the same species that are sharing that ecological role as them, that benthic kind of species, like an eastern sand darter, or a mottled sculpin, or a matatom as well. Next, they like to prey on the eggs of native and sport fish, from walleye to smallmouth bass, and other fish as well that people like to fish for. They also alter food web dynamics massively. They can become really abundant very quickly in certain habitats in certain areas, and that massively alters the food web dynamics, and they become a primary prey source for some of these predatory fish that people like to fish for. Lastly, they can transmit disease and act as a vector for disease, for VHS, viral hemorrhagic septicemia, and avian botulism, both that lead to either fish die-offs or aquatic bird die-offs. That leads to my project motivation. So these threats, or these impacts, these adverse impacts, and this inland radiation is getting close to Lake Champlain. They're threatening Lake Champlain in the north via the Richelieu River, as Scott mentioned, and the Champlain Canal in the south. They're roughly, I don't know why that keeps happening. It skips through long. They're roughly 50 to 60 miles away on both sides. Physical specimens wise, eDNA is a little bit different, but the managers in Lake Champlain are concerned about these impacts and the proximity to Lake Champlain. and where the impacts are going to be felt the most across the Lake Champlain watershed. That leads me to my main objective of my project, which is to try to, before they get to Lake Champlain, identify the habitats and the spatial extent across Lake Champlain where this is most likely to occur. So my final product will look similar to this picture that you see here, which was a 2008 species distribution model that the US EPA ran for Mount Goby, using things like temperature, water temperature, light refraction, I think, as well. And some very simple things. It was more of a project of 14 different species, so it's kind of a more simple model, but the output will look similar where you're going to have areas in red where it's likely areas of inhabitants and areas in blue where it's unlikely to have areas of inhabitants. The way to do this is I'll be using species distribution modeling. So in the simplest form, it's using species occurrence data combined with environmental data collected in similar regions or exact same sampling locations, and using that to predict species occurrence. So if you look on the left side, you have that species occurrence data. If you pretend the black circles are a spot where a round goby is present, and the white circle where a round goby is not present, and then you combine that with the environmental data, you can use that to predict where they're going to be. So on the right map, you see the green areas where they're likely to be, and the red areas where they're unlikely to be. And that's kind of the simplest form of the species distribution model. The project will be done in 2 phases, the first being data collection, the second being the actual modeling itself. So first, I'll be collecting round goby presence data from the Great Lakes. Most of that will be from the Great Lakes trawling surveys, the various trawling surveys across all of the Great Lakes. And then the next will be the AUV collected benthic imagery data that Peter Esselman from the Great Lakes Science Center is collecting. He's using underwater gliders and AUVs, really cool stuff, to collect these really high definition photographs of the benthic substrate as well as round gobies. And he's using machine learning to kind of help count round goby and get estimates of what the benthic substrate's looking like. Next, I'm going to combine that with the environmental data in the Great Lakes that's collected in similar locations to those trawling surveys or those UAV photography images. Primary covariates or environmental data of interest of season, water depth, benthic substrate, and water temperature, as I mentioned earlier. From there, I'll then collect environmental data for Lake Champlain. There's an image of the Lake Champlain Long-Term Monitoring Project, which will be one of the main sources of the Lake Champlain data itself. They have 15 lake sites across the whole lake. They collect a bunch of different water chemistry, water quality parameters. So I'll be using that, as well as the side scan sonar data that gets the benthic substrate data that was collected from Middlebury College. I think it was about 10 years ago now. I've been working with them to get a classification of benthic substrate for Lake Champlain, whether it be hard or soft substrate or cobble versus sand versus mud. We'll see how fine-tuned we can actually get that data. From there, we're going to combine all that data and run 3 different types of species distribution models. So a generalized additive mixed model, a GAM, a random forest, and then a range bagging. I'm still very much learning how to do that stuff. I'm more focused on the data collection phase of my project right now. And I forgot to say at the beginning of the talk, this is much more of a methods talk than a results talk. I'm hoping to be here next year and present a much more final finished product. From there, I'm using an ensemble modeling approach, so I'll be combining all 3 of these models and the results of their models to improve my accuracy and reduce uncertainty to create a better prediction for Lake Champlain. And to back things up, back to the management kind of implications of what we're doing and why we're doing things here, it's going to help inform the eDNA survey design, so a lot of the eDNA surveys that U.S. Fish and Wildlife is doing, Vermont Fish and Wildlife, etc. It's going to help inform that survey design to pinpoint locations of where we should be collecting eDNA and where we should not be collecting eDNA. Next, as the invasion develops, they're not in the lake yet, they have not been detected in the lake yet, but their invasiveness suggests that they probably will get in the lake eventually. So I expect that my species distribution models will help guide that management as things kind of develop. Next, we believe that it'll help local managers kind of assess any possible overlap with our state listed or endangered or SGCN species across both New York and Vermont, and even Canada as well. Things like the eastern sand dart, the channel dart, the mottled sculpin, maybe some mad toms as well. And lastly, it will help inform the ecosystem-based food web model There was a postdoc student that's connected to this project as well, as also funded under this project. He's recently moved on, but it's kind of this, my project will help inform that project as well. From there, I just want to acknowledge people that have helped along the way. Mark Henderson, my advisor, being the #1, the Lake Champlain Basin Program for funding the project, the people at the Brew Lab at the University of Vermont for providing helpful input, people at the Ohio DNR, University of Buffalo, U.S. Fish and Wildlife, Ontario Ministry of Natural Resources, New York State DC, and Vermont Fish and Wildlife. And from there, I'll take any questions.